Hi everyone, I'm Alif and Adres, and today I'll be presenting my final year project titled Analysis of Antibacterial Activity of Clitoria ternatia Methylenic Leaf Extract against Pseudomonas aeruginosa, Shigella sonnei, and Staphylococcus aureus. So Clitoria ternatia, or butterfly pea, is a well-known medicinal plant, and several studies have highlighted its potential antibacterial properties. With a growing concern over antimicrobial resistance due to antibiotic overuse, exploring natural alternatives like this plant could offer new ways to fight bacterial infections. The objective of this study were, first, to test whether C. ternatia leaf extract can inhibit the growth of the selected bacteria, and second, to determine the MIC and MBC value for this extract, which basically help us know how much is needed to stop or kill the bacteria. Previous research has shown that C. ternatia extract can inhibit growth of various pathogens, though the zones of inhibition recorded were relatively small, suggesting limited potency at lower concentrations. Chakraborty et al. 2017 reported that the plant contains several bioactive compounds such as flavonoids, tannins, phenols, and terpenoids, and these compounds are believed to be responsible for its antimicrobial properties. Now for sample preparation, I first cleaned and air-dried the leaf, then dried them further in the oven. The leaf were ground into a fine powder and soaked in 70% methanol for 3 days. After filtering and concentrating the extract with a rotary evaporator and a vacuum centrifuge, it was stored in refrigerator for later use. As for the antibacterial assay, I conducted 3 main tests: this diffusion to observe bacterial inhibition, MIC to identify the minimum concentration that can inhibit growth, and MBC to find the concentration that actually kills bacteria used. To confirm the identity and purity of the bacteria cultures, I used selective media, gram staining, and biochemical tests. S. sonnei appeared as pale colony on McConkey agar, S. aureus formed golden colonies on MSA, and P. aeruginosa showed a greenish color on TSA, which is typical for this species. Gram staining showed S. sonnei and P. aeruginosa as gram-negative rods, while S. aureus appeared as gram-positive cocci in clusters. Catalyst tests were positive for all 3 bacteria, indicated by the bubbling after adding hydrogen peroxide, and for the oxidase test, P. aeruginosa was positive, while S. sonnei and S. aureus were negative, consistent with their known respiration pathways. In the Dis diffusion test, no inhibition zones were observed for S. sonnei and P. aeruginosa, even at 200 mg per ml. For S. aureus, there was a mild inhibition, with the largest zone being around 8 mm. That's below the 11 mm threshold, generally considered to indicate effectiveness. This suggests weak antibacterial activity, especially against gram-positive bacteria. These findings are consistent with those reported by Das et al. 2020, who also observed an 8 mm zone of inhibition on S. aureus. However, contrary to my results, Islam et al. 2023 found 10 mm zone of inhibition on S. aureus at 100 mg/ml and 12 mm at 200 mg/ml. Other than that, Camilla et al. 2009 reported a 13 mm zone of inhibition on P. aeruginosa at 100 mg/ml concentration. This comparison highlights the limited antibacterial strength of the extract under the tested conditions. MIC values could not be determined because the readings from the microplate reader were inconsistent with random fluctuations. The extract's dark pigment and sedimentations likely interfered with the absorbance at 600 nm, leading to unreliable results with very high OD value. To illustrate the expected outcome, Camilla et al. 2009 reported the MIC value for S. aureus and P. aeruginosa was 50 mg per ml, and their MBC value were both 100 mg per ml. Similarly, the MBC test showed bacterial growth in all subcultures from extract-containing wells, even at the highest concentration. This means that the extract was not sufficiently bactericidal or having low bioactive compound concentration, which aligned with the results from the Dis diffusion and MIC assays. In conclusion, C. ternatia methylenic leaf extract had no effect on S. sonnei and P. aeruginosa, and only weak activity against S. aureus. No MIC or MBC values could be determined due to pigment interference and lack of bactericidal activity. This suggests the extract in its current form is not effective as an antimicrobial agent against this bacteria. For further study, I recommend testing higher concentration above 200 mg per ml and assessing toxicity if those doses are to be used as antimicrobial agents. The extraction method should also be improved, especially to remove plant pigments before MIC testing to avoid optical interference. It is also important to prepare the extract fresh and avoid long storage, as that may degrade bioactive compound or leads to contamination. Lastly, I suggest conducting phytochemical analysis using methods like HPLC or GC-MS to confirm whether the key antibacterial compounds are actually being extracted. Here are the references used throughout this study. That is all from me. Thank you all for listening.